we're going to find the 5 remaining trigonometric functions for an angle theta. We're given that tangent of theta is negative 12 divided by 5, and we know that theta is between pi over 2 and pi. That puts that in quadrant 2. If we let point xy be on the graph of a circle, x squared plus y squared equals r squared, we know that tangent of theta is equal to y over x. Now we have a negative value for the tangent, so we need to determine whether it's y or x that's negative. Since we're in quadrant 2 on our circle, we know that it's the x value that's negative, so we can write this as 12 over negative 5. Therefore, our point, Pxy, is equal to negative 5, comma 12. And then we can use that to find our remaining trig functions. First, we're going to need to find the value for r. Since we know x and y, we'll put those values in. X squared plus y squared equals r squared. That's our circle. X is negative 5. Negative 5 squared plus 12 squared equals r squared. And if we solve this for r, we'll get that r is equal to 13. Remember that r is the radius of the circle, so it's going to be a positive value. Now we know x, y, and r, we'll find the remaining 5 trig functions. We'll start with sine. The sine of theta is equal to y over r. We know that y is 12 and r is 13, so we get sine of theta is 12/13. For cosine theta will be x over r. Put in our value for x, that's negative 5. R is 13, so cosine is negative 5 over 13. Tangent of theta will be y over x. Again, putting in our values for y and x, we'll get negative 12/5. Cotangent, I guess we already have tangent of theta up there. Cotangent of theta is equal to x over y. Plug in our values for x and y, we'll get negative 5/12. Secant of theta will be r over x. Plug in our values, and we will get r is 13, x is negative 5, so negative 13/5. Cosecant theta is equal to r over y. We plug in our values. R is 13, y is 12, and so we'll get 13/12.